multi-step inequalities. This is where we're headed with our inequality problems that we've looked at in the last two sections. We did one-step inequalities. Now we'll do multi-step inequalities. It could have 2, 3, 4, 5 steps, depending on the inequality itself. Now this is going to, again, be a lot like how we solve multi-step equations, with the exception, of course, being that if you multiply or divide by a negative, you must reverse the order of the inequality sign. Now before we get to the actually solving them in the traditional way, let's go by definition. It says, tell whether the given number is a solution of 7x minus 6 less than or equal to 4x plus 5. Because the variable is written twice, the value in question, negative 5, has to be plugged in both spots. This is 7 times negative 5 minus 6 less than or equal to 4 times negative 5 plus 9. 7 times negative 5 is negative 35 minus 6 less than or equal 4 times negative 5 is negative 20 plus 9. This is like adding the opposite, like adding the opposite. This is negative 41 less than or equal to a negative 20 and a positive 9 is negative 11. And negative 41 is less than or equal to negative 11. So my answer is yes. That's a true statement. Now we'll solve and find all the solutions. We'll also graph them on the number line. The first one is a two-step inequality. There are two things being done to the variable. We're going to try and isolate the variable. We have to get rid of the 4 that's times it and the 7 that's being subtracted. So the first thing that goes is, if you remember, we undo subtraction or addition before we undo multiplication. To get rid of the minus 7, I'm going to add 7. So I'm just using a little shortcut notation here. Way of writing it out, I get 4x is greater than or equal to 12. Notice I do not switch the sign around. You never switch the inequality sign when you add or subtract from both sides. Now I'm going to solve for x. I'm going to get rid of the 4 that's times it. I'm going to divide by 4. And I'm dividing by a positive 4, so the order, again, remains the same. The 4 in the numerator and the denominator cancel out as a factor of 1. That's 1x, or x is greater than or equal to 3. So I'm going to graph this on the number line. Because of the equal to, it's a filled-in dot. And x is greater than or equal to 3 means I'm going to want all the values bigger, so that's to the right. Again, look at the way the inequality sign is pointing. If the variable's on the left side, the way the inequality sign appears to be pointing is the same way that you shade. This is pointing to the right, or at least it looks kind of like it is, and this is shaded to the right. The next one up is also a two-step inequality. I'm going to first get rid of the minus 2 before I get rid of the negative 5 that's dividing. To get rid of a minus 2, I'm going to add 2. Now this time I'm going to write it all out. I'm going to add 2 to this side, and I'm going to add 2 to this side. The minus 2 and the plus 2, that adds up to 0. There's the canceling effect, and I get w over negative 5 is less than or equal to here. Negative 6 and 2 is negative 4. Now I'm going to get the variable w all by itself by getting rid of the negative 5 that's dividing into it. The inverse of dividing by negative 5 would be to multiply by negative 5. Now we have to be careful. I'm multiplying both sides of an inequality by a negative number. We must reverse the order. So this becomes greater than or equal to. The negative 5, which is the same as negative 5 over 1, they cancel out. That gives me 1w, where w is greater than or equal to negative times negative is positive, positive 20. So if I go to graph the solution here, my key value is 20. Because of the equal to, I want to include 20, so it's a filled in dot. And greater than, again, because the variable's on the left side, it's pointing this way, I'm going to shade to the right and put a big arrow there. My next example has the variable on both sides. This is why, when I was showing you how to solve multi-step equations that had the variable on both sides, I always said get rid of the one with the smaller coefficient. That way you'll end up with a positive amount of them. And when you divide, you'll be dividing by a positive, and you won't have to worry about reversing the order. So in this case, I have 5y here, I have 1y here. Remember, there's no number in front of the y, it's like a 1, it's understood to be there. I'm going to get rid of the 1y by subtracting 1y from both sides. 5y minus 1y is 4y, plus 2 less than or equal to 34. Now it's much simpler, it's a two-step. I'm going to get rid of the plus 2 by subtracting 2, undo the adding before undoing the multiplying, so I'm going to subtract 2 from both sides. I get 4y is less than or equal to 32, and now I'm going to divide both sides by 4. And because I'm dividing by a positive, the order stays the same. I have 1y, or y is less than or equal to 8. I draw my number line here, I put the 8. Because of the equal to, I want to include the 8 as part of my solution, and because it's less than, I want the value smaller. Again, the variable is on the left side. It looks like it's pointing to the left. I shade to the left. One more inequality. Notice that this one has parentheses, so I have to simplify the left side first. Remember, we always simplify both sides of the inequality or equation first. That's our very first step. I have to distribute. Now be careful, you're distributing by a negative. Negative 2 times x is negative 2x. Negative 2 times minus 3, that's like plus 3. Excuse me, it's like plus a negative 3. Negative times negative is plus positive 6. Less than 13. Negative times negative, positive. Now I'll subtract 6 from both sides. And you can see here that in this case, I am not going to get a whole number. I'm going to get a mixed number of some type here. I'm going to divide both sides by negative 2. Now, because I'm dividing by a negative 2, the order reverses. These cancel as a factor of 1. I get 1x as x is greater than 7 divided by negative 2. 2 goes into 7 3 1/2 times. X is greater than negative 3 1/2. It does not ask for the graph. The last example is a story problem. A dance group charges $15 for membership. Members pay $8 for admission to monthly dances, and non-members pay $12. So how many dances does Dave need to attend for the cost of his membership to be less than paying as a non-member? So I went ahead and let X represent the number of dances. Now, if Dave is a member, he has to pay $15 up front and $8 a dance, so that would be 8 times X. We want to know what this has to be so he's paying less than a non-member. A non-member pays $12 per dance, so that would be 12x. So now in this problem I'm going to solve. Notice the variable on both sides of the inequality. I have less on the left than I do on the right. I'm going to subtract 8x. I have 15 is less than, this is going to be 4x. Again, it looks like I'm going to get a fraction here. I divide both sides by 4. And 15 divided by 4 is 3 3/4. So x is less, 3 3/4 is less than x, which means x is greater than 3 3/4. So since x is the number of dances and you can't attend 3/4 of a dance, he's got to attend at least 4 dances to make that membership pay off for him, so that he's paying less than a non-member that attends the 4 dances. So he needs to attend at least 4 dances, and then it'll pay off. Now the inequalities, as you can tell from section 4 to 5 to 6, got progressively more difficult, so don't forget to practice, practice, practice.